Okay, so the topic that we are doing over here is specific resistance or resistivity of a material. Now see, resistance of any wire is directly proportional to the length of the wire. Of course, this is all these when we are keeping some of the conditions constant, like temperature is kept constant. So resistance of any wire is directly proportional to the length of the wire. As the length is increased, the resistance of the wire also increases. Then resistance of the wire is inversely proportional to the area of cross section. Area of cross section we mean to say the thickness of the wire. It is inversely proportional to the thickness of the wire. It means if you are going to have a thin wire, then its resistance is going to be more. If you are going to have a thick wire, then its resistance is going to be less. So these are the two things on which the resistance of a wire is going to depend on. There is one more factor on which the resistance of the wire depends, that is what kind of material it is. So over here we are going to replace this with a constant and we are going to write this equation. R is equal to rho, this is rho, this is the symbol of rho, into L upon A. Okay, rho is the specific resistance or resistivity of the material of a wire. R is going to be the resistance in ohms. L is going to be the length in meters. A is going to be its area of cross section, which is going to be in terms of meter square. So we are also going to write down the definition of specific resistance. I'm just going to rearrange this equation. I'm just going to bring this L and A on the other side. So what I'm going to have over here is R multiplied by A divided by L is equal to rho. So this is basically going to give us, on rearranging this equation, this is basically going to give us the units of specific resistance. The units of resistance is going to be ohms. The unit of area, that is area of cross section, is going to be meter square. And the unit of length of the wire is going to be meters. So I can cancel one of the M over here. So the unit of specific resistance is going to be ohm meter. Okay. So this is the unit of specific resistance. I'm also going to take up the definition of specific resistance. Here we are going to write the same equation over here. Once again, R is equal to rho multiplied by L divided by A. Suppose over here, if I'm taking the length of the wire is 1 meter. The area of cross section is 1 meter square. So it is having unit length and unit area of cross section. In that case, rho, over here both of these values are going to become 1 and 1 is going to become R, is the specific resistance of the wire is equal to the resistance of the wire whose length is equal to 1 meter and whose area of cross section is 1 meter square. We are just going to write that definition down. We are going to write this formula. You're going to write the units, as well as we are going to solve some numericals. So in simple language, if we try to understand the meaning of resistivity or a specific resistance, you take a material of wire whose length is 1 meter. Its area of cross section or thickness is 1 meter square. Whatever is the value of resistance that this wire is having, that is equal to its resistivity or specific resistance. We are going to solve the numericals based on this. Okay, so this is the first question based on resistivity. A metallic wire has resistance of 1 ohm per meter. Find the total resistance of 4 times the length of the wire. Now this is a straightforward unitary method. 1 meter is 1 ohm. So 4 times the length means 4 meters. Obviously this resistance is going to be 4 ohms. The next question, what will be the resistance of a wire 2.5 meters long wire? Okay, so this obviously is going to be again 2.5 ohms. It's 1 ohm per meter. So 2.5 meters will have resistance 2.5 ohms. The last of this question, what will be the resistance of a 6 meter long wire of the same material but with 4 times the area of cross section? Now see, 1 meter length is having resistance of 1 ohm. So 6 meters length, this resistance obviously will be 6 times because it is directly proportional to the length of the wire. So this is going to be 6 ohms. Now the other condition that they have put over here is that area of cross section is 4 times. Now if area of cross section is 4 times, as we know that the resistance of the wire is inversely proportional to its area of cross section or the thickness of the wire. Therefore, over here, okay, because here the area of cross section is 4 times, its resistance is going to become 1/4. Okay, because its length is 6 times. So its resistance will become 6 times, but its area of cross section is 4 times, so its resistance will become 1/4. So if I'm going to calculate this value, it is going to be 1.5 ohms. If you have any questions, you can ask me. Otherwise, I will take up the question that you have sent me. Okay, so this is the question that you have sent me. A 1.0 meter length of the wire is found to have a resistance of 40 ohms. What would be the resistance of a piece of the same wire of length 2 meters? Now this is a very straightforward question. If a wire is there of 1 meter, its resistance is 40 ohms. If its length is 2 meters, how much will be its resistance?
80.
This is going to be 80 ohms. Now the second part of the question, what would be the resistance of a 2 meter wire with half the cross section area made of the same material? Okay, now 2 meter wire is having resistance of how much? It's having resistance of 80 ohms. Now what you are doing, you are making half the cross sectional area. Now cross sectional area, the resistance of the wire is inversely proportional to its cross sectional area. It means the thickness of the wire. So if you make the cross sectional area half, its resistance is going to become double. Okay, so this 80 ohms is going to become 160 ohms. This is going to be the answer. If I say that if I have reduced the area of cross section into 1/3, then its resistance will become 3 times. If I say that I have reduced the area of cross section into 1/4, its resistance will become 4 times. Why? Because resistance of the wire is inversely proportional to its area of cross section. You can just take that down and we will take up the next question. Okay, this is the next question. Calculate the resistance of 1 kilometer long copper wire of radius 1 millimeter. Okay, it's a circular wire whose radius is given 1 millimeter and resistivity of copper, that is rho, its value is 1.72 multiplied by 10 raised to minus 8 ohm meter. So we have the length of the wire. This is 1 kilometer. Convert this into meters. This will be 1000 meters. The radius of the cross section given is 1 millimeter. That is 1 upon 1000 meters. Now we apply the formula R is equal to rho into L upon A. It's a circular wire like this, and here we are given the radius. So the area of the cross section we are going to apply, it is going to be pi r square. So I'm just going to substitute all of these things over here. This is going to become, okay, rho over here, the value is given 1.72 into 10 raised to minus 8 multiplied by, this length is 1000 meters, so this is going to be 10 raised to the power 3. I'm just going to write this area of cross section in the proper format. This will be written over here. We can write this as 10 raised to minus 3. So that's pi r square, pi into radius square, that is 10 raised to minus 3 square of this. I'll just do the calculations. This is equal to 1.72. This is 3.14. All the decimal power, all the index powers together I will take. 10 raised to minus 8. This is 10 raised to 3, so plus 3. 10 raised to minus 3 square is going to become 10 raised to minus 6. If I bring it in the numerator, it is going to become 10 raised to plus 6. I just have to do this calculations and I'm going to write down the answer. 0.54 into 10 raised to 1. So this is going to become 5.4 ohms. You can take down this. If you have any questions, you can ask me.